Right, this is about chapter 0 of our M2 syllabus. In this chapter, we will talk about some basic knowledge which we will use as for further chapters. The first one will be about rationalization. Now, take a look at this example. Look at part A first. Now, if we look at the instruction here, you are asked to rationalize the expressions. Now, if you look at the word rationalize, it actually comes from the word rational. It means we want to make the number rational. And therefore, if you look at the example in part A, you can see that the denominator consists of an irrational number, square root 3. And usually, we may need to rationalize the denominator for further calculations, because if the denominator is irrational, it is not easy. Say, if you want to add two fractions together and have an irrational denominator, it is not easy to have a common denominator. That's why usually we will rationalize the denominator before further calculations. And if you look at this irrational number, square root 3, and how can we make it rational? If we multiply with itself, okay, square root 3 times square root 3, and which is actually square root 3 square, and we have 3. And therefore, it means if I multiply square root 3 with itself, then it becomes a rational number. And we just use this idea, and then you can look at the solution here. We have square root 3 in the denominator, and then we multiply with square root 3. And in order to keep the fractions unchanged, we have to multiply the same number to the numerator. And that's why we multiply the whole fractions by square root 3 over square root 3. And then we just do it by just treat them as usual fractions. We multiply the numerators together, we multiply the denominators together, and therefore we have 9 times square root 3, which gives us 9 square root 3. And for the denominator, we have 2 times square root 3 times square root 3. It means 2 times 3. That's why we have 6. And actually, after this step, we have completed the process of rationalization. And then at the end, we just further look at the fractions and see whether we can further simplify the fraction. And in this case, we can see that there's a common factor, 3, in both numbers 9 and 6. That's why after the cancellations, we have 3 times square root 3 over 2. And then this is the result that we want to have. And actually, you can further check these two numbers, 9 over 2 square root 3 and 3 square root 3 over 2. They are just having the same values, but they just look different. Okay, we are rewriting the fraction. We are not changing the fraction. Okay. Now, then we look at part B. Now, in this case, you can see that this time the denominator is a bit more complicated, and because instead of having one irrational number, the denominator consists of two terms, 1, 2, and these two terms consist of two different irrational number. One is square root 3, and then the other one is square root 2. Now, imagine if you, for example, okay, we have this one, and then we apply the similar idea as we have done in part A. We multiply a number, right? We multiply the denominator with a number. And if I want to say get rid of square root 3, I multiply with square root 3. But if I just multiply with square root 3 only, we can try first. In this case, we have 4 times 3 minus 3 square root 2 times square root 3, and this part is square root 6. And therefore, in this case, it is still an irrational number. I mean, the denominator still consists of an irrational number, and therefore we have not completed the process. Now, and then you can imagine we will have similar results if I just multiply with square root 2, okay? That in this case we have 4 times square root 3 times square root 2 and then minus 3 times 2, okay? This term is rational, but the first term is still irrational. Therefore, it means we cannot rationalize by multiply with just a number with only one term. And therefore, in this case, you may think, can we just multiply with this number itself? Now, if I multiply with the same number, then it can be written in this way, okay? Is square of a binomial, and then or you can call it just like it looks like the identities are both perfect square. Then if we expand this one, we have 4 square root 3 whole square minus 2 times 4 square root 3 times 3 square root 2, and then plus 3 times root 2 and the whole square. Now, then in this case, this one becomes 16, sorry, 4 square, okay, and we have 16 times 3, of course it is a rational number. And then the last term, okay, here will be 9 times 2, okay, it is also a rational number. But the middle term is a problem. If you look at it, then you can see it carries square root 3 times square root 2, it means square root 6. Therefore, it means this one also consists of irrational term, and then we will see that if we multiply something like that, this one we have the square of this one, and we also have the square of the second term 3 root 2, but this term is unwanted, okay? This term is unwanted. Therefore, instead of multiplying with the same number, do remember, okay, I want to have a result with squares only, a square of numbers only, okay? Then in this case, say, do you remember if I can do something like that? Okay, instead of multiply by 4 square root 3 minus 3 root 2, we multiply with 4 root 3 plus 3 root 2. It actually comes from the result of this identity, a minus b times a plus b. It is simplified to be a square minus b square, the difference of 2 square. And therefore, in this case, if I multiply these two, it is 4 square root 3 whole square minus 3 root 2 whole square. It means 16 times 3 minus 9 times 2, which is 48, minus 18, which is 30. Okay, it is a rational number this time. And therefore, to handle a denominator like that, if I want to rationalize the denominator, okay, the idea is that we need to multiply with a number, but not the denominator itself. A little bit different, but it also looks a bit similar. Okay, we will multiply with 4 square root 3 plus 3 root 2. Okay, here 4 square root 3 plus 3 root 2, because just I explained, we are rewriting the fractions. We are not going to change the values of the fractions. Okay, and then we just multiply the numerators together. 15 times 4, 60 square root 3 plus 45 square root 2, okay, divided by 30. Just now we have calculated the value. And then if you look at this again, we can cancel each term by 15, because 15 is the common factor. Therefore, it is 4 square root 3 plus 3 square root 2, and then divided by 2. Okay, and then you can try the exercise in your worksheets, and then we will look at some more example next time.